Good morning, ladies and gentlemen. Welcome to our today's webinar. Today we will speak about our new product, the Bifacial one, and we have online our Vice President and Chief Scientist, Pierre Verlinden, who will go through the presentation. The presentation will take approximately 20 minutes. And if you have questions, then please write it in the question pane or in the chat. After the presentation, we will go through the chat and the question pane and answer all your questions. And I will hand over now to Pierre, who will go through the presentation. And you also see that you have the chance to meet us at the Intersolar. And for sure, we will record the webinar as well and distribute it after the webinar.
Okay, thank you, Stefan, and I'll share my screen. Here we go. So good morning, everybody. It's great to introduce to you our new product, the DUOMAX Twin, and I'll start immediately with the presentation. When you look at the different markets for photovoltaics, you could see that there are so many different markets. We can kind of categorize them in three categories. One is the LCoE driven market, which is basically utility and commercial PPA driven. What's mostly important is the dollar per kilowatt hours, bankability and reliability. But there are other markets like the residential market, where it's very important to have a short payback time. What's important is the amount of money that the end customer pays, the dollar per kilowatt, and how many kilowatt hours they will produce per year. That they will calculate with a very simple financial model, the payback time. And then there is a niche market where the most important thing is the power density, how many watts per square meter you get. This is typically small roof residential architecture product, EVs, boat, airplanes, blimp, etc. Today we'll focus on the LCoE driven market, and we'll talk about how to increase LCoE for the customers. LCoE, as you probably know, means levelized cost of electricity. So what is the real cost of the kilowatt hours that you produce over the lifetime of the modules of the PV systems? So to calculate the LCoE, you have to sum all the costs of the system, including the financial cost, the permitting cost, etc., and you discount those costs, the future costs, you discount them to the present value. So for example, the maintenance over 25 years, you have to discount that. And you divide that by the total amount of energy that's been produced during the lifetime of the system, and also you have to discount that energy to the present value. So how to increase LCoE to get to improve LCoE, so decrease LCoE, how to get the low LCoE and a good value for the customer. Of course, you have to have low cost, and particularly low cost of installation and low cost of material, high reliability, and very high energy production rate. So we're going to talk about how to reduce LCoE, and particularly looking at the energy production rate, which is basically improving the energy efficiency of the modules. Why is efficiency so important? If you look at the graph on the right-hand side of the slides, you see that at the bottom, the horizontal scales give you the levelized cost of electricity, LCoE, in cents per kilowatt hours. The different blue curves corresponds to the module efficiency, and the vertical axis, the module cost in dollar per square meter. The red star represent roughly where we are right now in the industry, modules that are roughly about 15% efficient if you take the whole array of the modules, at a cost of roughly about $60 per square meter. to reduce the LCoE to level like 2 cents or 3 cents per kilowatt hours, you see that there is no other option than improving the efficiency of the cells. And improving the efficiency is mostly related to the cell process and cell design, which represent only 20% of the overall cost of the module. So it's very important. The efficiency impacts everything, impacts the dollar per watt of all the other components of the module, but impacts also storage, transportation cost, packaging cost, land cost, labor cost, etc. Of course, LCoE depends on the location and the irradiance. So that's why bifacial modules is a good approach to improve LCoE. So you could get up to 25% more energy. When I say up to, it depends, of course, on the location and the design of the system. But basically, the new product that we're offering right now, the bifacial dual glass module, DUOMAX Twin, offered that possibility to increase the amount of harvested energy up to 25%. The customer benefits are, of course, more energy. You get between 5 and 25, depending on the location. Automatically, you get a lower LCoE. It's a dual glass module, so you get high reliability. And you could use that modules in a very wide range of application. Could be, of course, ground-mounted project, particularly if you have a highly reflective ground like sands or desert application, but could be also on water, agriculture project like greenhouses, for example, and sometimes on some roof also if the roof is highly reflective. And on top of that, you get all the benefits from all the great advantage of DUOMAX module, which is no microcrack, best reliability under thermal cycling, humidity freeze or dam heat, the best PID resistance. The module is capable of 1500 volts, less soiling because there is no frame, so the frame doesn't catch dust at the edge of the module. No cell tracks because there is no microcrack and no water ingress, and basically you solve the backsheet abrasion issues in desert application. How does that work? Well, it's not very difficult to understand how it works. Basically, you get a cell that is bifacial, so the backside of the cell is not fully metallized, but it's metallized with a grit like in the front, and could collect light from both sides. You have a modules that's a dual glass module and 2 clear EVA sheets, so the light could reach the backside of the modules also. And the module collect light that is reflected by the ground. That's called the albedo. There are 2 types of bifacial modules, N-type and P-type. N-type is the most efficient one. It's also the most expensive one. The P-type is a little bit less efficient and much cheaper to produce. The difference in the N-type, it requires an additional diffusion at the back in what's called a back surface field, N-type back surface field at the back, and the metallization is more expensive. Also, the wafer, the substrate on which we make the cells, is more expensive. In general, the cost increase for a N-type bifacial modules is in the range of 20 to 25%. However, you get extremely good rear efficiency, almost the same as the front efficiency. So if you do the ratio between the two, what's called the bifaciality ratio, you get the bifaciality ratio in the range of 90 to 95%. And this type of module is ideal for vertical installation or installation where you have a very highly reflective ground like snow fields. However, the P-type might not have the same type of efficiency, but it's much cheaper, only 6 or 7%. And the reason it's because it's just a simplified metallization at the back. You have, it's a PERC cell, to start with, and the back, instead of being fully metallized, you have a grid type design at the back. However, because the carrier lifetime inside the P-type material is not as good as N-type material, the rear efficiency, it's only 65 to 70% of the front efficiency, about 14%. And it's ideal for all the other ground-mounted application or application on water, for example. The N-type, like I said, bifacial modules is ideal for vertical configuration. In that case, the module is placed vertically and receives sunlight from the morning to the afternoon on both sides of the modules. But these applications are relatively small, and because the N-type bifacial module is more expensive, we think that the advantage for the customer is very low. So we focus on the P-type bifacial module. First question, what is albedo and what's the reflectance of the ground depending on the type of ground that you receive? If you look at the graph on the left side of the slide, you will see that the snow, and you can imagine the snow is highly reflective. The snow, the fresh snows give you the best reflectance, the best albedo, about 80 to 85%. If you fly on an airplane, if you look at clouds, you could see that cumulus, for example, are highly reflective also. But on the ground, the best reflectance is, of course, when you have snow or desert. Desert gives you about 25 to 30% reflectance of the ground. Whereas grass gives you something between 10 and 20%. So how do you calculate the additional energy that you could generate with the bifacial modules? You have to take the front side output, multiply by the module bifaciality, and multiply by the albedo. So with the P-type modules, you have module bifaciality ratio of about 70%. The albedo is given by the type of ground surface that you have, and that gives you the additional energy that you could expect it. For example, for grass, you have an albedo of 10%. You have an additional energy that is in the range of 7%, so greater than 5. On concrete, you have a little bit more reflectance, and you could get an additional energy up to 10%. If you put your modules on a tilt system with a roof that's painted white, you could get up to 15% additional energy. And if you place the module above snow, fresh snow gives you more than 20%. And of course, that is assuming that nothing prevents the light to reach the rear surface and to be uniform on the backside. And I'll come back on that a little bit later. So the product that we are presenting today, the DUOMAX Twin, it's a P-type monocrystalline PERC cell. So it's a high efficiency cell. It's the system voltage up to 1500 volts. We present those modules with 60 cells or 72 cells, so you could get 290, 295 watts with 60 cells, or 344, 345, 350 with 72 cells. The additional power gain between 5 and 25% depending on the ground. And it's, of course, a dual glass module with 2.5 millimeter high transmission glass on both sides. The product features a good design of the junction box. As you could see, the junction box, it's a split junction box. You have 3 small junction boxes that do not prevent the light to reach the cells. That's very important. Probably you have seen some bifacial modules from other manufacturers, and if you look at the backside, the junction box are somewhat covering partially the cells on the backside, which is not a good design. Also, the module comes with a corner protection and good edge banding to protect edge and corners against shocks, and that could happen during the installation and transportation and handling of the module. Also, it's very important to use the right clamps when you attach the modules in the frame, and you could see in those design here, it's very important to put the rails at the edge of the modules and to use the right number of clamps to get a good mechanical loading resistance, up to 2400 Pascal on both sides. Typical applications are utilities, desert, over snow, vertical applications like street lamps and noise barriers, BIPV like this picture here, or agriculture projects on greenhouse or carport, for example. This is a quick study of the power gain that you could get with bifacial modules as a function of the ground albedo. And this result comes from many different experiments that are happening right now around the world, and we try to collect all of those data into one graph. So if you could see, if you increase the ground albedo, you increase the energy gain, could reach up to 25% with this type of modules, with a P-type bifacial module. We've done some tests in Changzhou, in our headquarters in China, and I'll give you a quick summary of that. So this experiment is comparing bifacial P-type modules with standard dual glass modules. And this is done in Changzhou, in China, with a grass ground. You could see that on an experiment that lasts a few months, from June to September 2016, we got about 7%, 6.94% additional energy for the same kilowatt peak. So we compare here the energy yield, kilowatt hours per kilowatt peak. And if you look at the second graph on the right-hand side, you see the energy yield improvement as a function of the daily radiation. You could see it's almost flat. It doesn't really matter if you have high irradiation or low irradiation, but you could see at very low irradiation it drops a little bit, but it's roughly between 5 and 8%. In average, about 7%. This is another experiment which also happened in Changzhou. It's a commercial demonstration where you have, on the same ground over water, you have 36 kilowatt of multicrystalline modules, 36 kilowatt of bifacial modules, but with the rails blocking partially the lights of the backside of the modules, and 36 kilowatt of bifacial modules with no back rail shading the backside. You have a drawing here showing the three 36 kilowatt systems. So same inverter, same location, same climate. The only difference is the non-bifacial module, the bifacial module with the rail blocking the light, and the bifacial modules in landscape installation with the rail not blocking the backlight, the rear light. And this is the field performance. You have in gray the energy produced by the baseline multi-modules. In red, the energy produced by the bifacial module, but with the back rail partially shading the backside. And in blue, the bifacial modules mounted in landscape orientation with no back rail blocking the light on the rear sides. And you could see that the maximum gain in energy is about 17%. And in average between January and March, which is winter in Changzhou, an average gain about 8% if you have no rear shading. So what's the influence of the rail on the backside? And this experiment shows that different bifacial modules with back rail from 0 to 270 millimeter, you could see that the short circuit current of the module is reduced. And of course, it's reduced the most when the back rail is very close to the module. You lose about 3% of the light if you block the light with a black rail. So if you have to be very careful when installing bifacial modules to keep a large gap of at least 50 millimeters between any back rail and the module itself. And we have other tests ongoing for the moment in Huangshan in the Anhui province in China and Huanghe project. Up to 20 megawatts of bifacial modules are being installed right now, and data will be collected. LCoE gain. This is a very interesting graph and probably the most interesting for you. How much can you lower LCoE with bifacial modules? And we compare here with standard mono modules for an average irradiation of about 900 kilowatt hours per square meter per year, which is roughly about the case in middle Germany. And it's a ground-mounted system with a size of 10 megawatts. So we calculate the LCoE compared to the standard mono. PERC mono gives roughly about the same LCoE for that location. With P-type bifacial, with grass background and 5% gain of power, LCoE is reduced by about 4.63%. If you have a better background, like a more reflective concrete, and you get 10% increase in power, you could reduce your LCoE by about 9%. If you put the modules on trackers and you have a white background and you get up to 15% gain, you could lower your LCoE by 8.5%. And if you put that modules on trackers, and I'm talking here about one-axis tracker, one-axis horizontal tracker, and on snow, you could get a reduction of LCoE up to 12%, more than 12%. So, in conclusion of this presentation, bifacial modules give you a great opportunity to increase the power, increase the energy, lower the LCoE, but the very important thing is that you need to select the right location and design the system such that there is no blockage of the light on the backside. Well, thank you very much for your attention, and I'm happy to answer some questions now. Stefan, it's up to you now.
Yes, thank you very much, Pierre, for the great presentation. There were some questions regarding the slides and the recording, though after the complete presentation we will share the slides as well as the question and the answers. Let's start with some questions. The first question would be, or is, what about the influence of the distance to surface and inclination? Pierre?
Sorry, I had muted my microphone.
Okay.
Sorry. It's a great question and very good. And the distance needs to be as large as possible. As I showed before in previous slides, if you have an object blocking the light to the backside, the power output is reduced. So if you put the module very close to the background, so for example in a roof-mounted system with the modules only a few centimeters from the roof, there's not much albedo, there's not much reflected light there. So the bifacial modules are best for ground-mounted systems. If you put them on roof, the modules need to be away from the roof as much as possible, or tilted. That's also another possibility. So if you have a flat roof which is painted white and the modules are tilted, that is a good design. But try to avoid any blockage from the back rail. Try to increase the distance as much as possible from the reflecting surface, the reflecting background. The more distance, the more albedo you will get.
Okay, there's another question. Do we already have experience with single-axis tracker yield gain applying bifacial modules?
Yes, we do. I didn't show that in my presentation because of lack of time, but we, in Changzhou, we're doing a lot of experiments with different type of backgrounds. Grass background, sand, white, grass, all type of grass, with tracker or fixed tilt or a different type of system racking design. It's a bit difficult to show all of that data in one presentation, but yes, we do. I suggest that you send us an email, and we could send you some more detailed data if you need to.
Okay, great. Another question is, some manufacturers claim power gains of 35 or even 40%. Is this realistic compared to standard modules that's independent from the cell technology used for bifacial?
Well, like I showed to you, the additional energy or additional power you get is depending on many factors. The first factor is the bifaciality ratio. The second factor is the reflected light, and the third factor is the type of racking design that you have. So to get up to 35%, which is extremely optimistic, you need to have a very high bifaciality ratio and very good background. So if you have a P-type modules with about 70% bifaciality ratio, and you have snow, fresh snow up to 80% or 85% albedo, yes, it's possible, but you don't have that all year. And so over the years, getting 35% energy gain, it's extremely difficult. I'm much more comfortable saying that you could get 25% if you design it well and if you locate it well. If you want to get 35%, you need to really make sure that your design is correct. But so, for example, if you put on snow, you will get that maybe 3 or 4 or 5 or 6 months per year. Over 1 year, it's going to be very difficult to get 35%. So I feel comfortable with 25.
Okay, and this brings us directly to the next question. How does the albedo gets affected by the soiling over time? That means soiling on the, let's say, surface, on the reflective surface, and even on the, let's say, module backside.
Yeah, there's very little soiling on the module backside. There is soiling, of course, on the front side, and for that reason, the dual glass module without frame is absolutely ideal to avoid soiling. But of course, modules need to be cleaned regularly. The degradation of the albedo is it's an important factor. Effectively, if you have grass, for example, which is relatively good reflector, between 10 to 20%, when the grass dies and shows a dark ground, the albedo drops. And so you need to maintain a very highly reflective soil underneath the modules. The best is to use sands. Reflective sands is probably the best albedo you could get, and with the lowest maintenance. Or if you could paint the background white, if you're on roof, for example, it's also a good point. But it's true that you have to make sure that your albedo doesn't degrade over the years.
Okay, great. We have a lot of more questions, so we will answer one more question. And if you have more questions, then please write in the question pane. After the webinar, we will go through all the questions raised during the webinar and answer it, and then you will get the answers with the follow-up. The last question, what we would directly answer is if you already have tested it under hot conditions or hotspot conditions. Let's say if you have shading on the backside, what you already showed that we have a power difference if we have shading on the backside with rails or no shading.
That's a excellent question. That's absolutely right. So when you have a module that is not bifacial, on the front side you have usually a uniform sunlight unless there is some birds dropping or leaves or soiling on the module. But in general you have a very uniform illumination. On the back side it's not always the case due to the nature of the reflector of the background and due to nature of surrounding and the rack design, etc., and the position of the sun. You may have not so uniform lights on the back. It's true, and so you could happen in a situation of hotspots. Fortunately, the background or the rear illumination is not as powerful as the front, and the mismatch between cells it's not significant. So you don't have much mismatch, and the risk of degradation of reliability of the module is not great. We tested all of that, yes. We test that in laboratory, we test that in the field, and we have not seen any additional reliability issue with this factor. But to make, I want to point out again that the system developer needs to design the system for a bifacial modules, which means that you don't put the bifacial modules, you don't mount them the same way as you mount the normal modules. You have to make sure that the rails are at the edge of the modules and parallel to the long side of the modules. So in most cases you're going to mount the modules on the landscape orientation and have the rails between modules.
Okay, great. Thank you very much, Pierre, for the great presentation. Thank you very much to all attendees we had today in our webinar. As I said in the beginning, we are, or you can meet us in the Intersolar if you have, want to have more discussions, more detailed discussion about, then you're welcome to visit us on the Intersolar and discuss with us your questions. Thank you very much, Pierre. Thank you very much.
You're welcome.
To all our attendees, I hope you enjoyed our webinar. It was great from us to have this opportunity to have Pierre here as presenter, and I want to wish you a nice and sunny day. Thank you very much. Have a nice day. Bye.
Thank you. Bye-bye.